Theater and physics. They are interesting topics to look into in their own regard, but how often do you hear about them in the same conversation? This is exactly what I would like to discuss with you today. These are both two fields that also often have their worth called into question, or at least their relevance or significance. Often appreciated occasionally or in set or stereotypical ways, many people often don't see just how important these fields are to everyday life. People usually think any art and science are polar opposites, never even imagining how they could both be combined. Helen Zursky, a British physicist, said in a TED Talk, "We have our societal view of physics. We think of really small things like atoms or really big things like stars. It's a weird thing done by weird people in weird clothes." And outside of maybe going to some Broadway musical or reading a Shakespeare play in high school, people can wonder, what's the big deal? One of the first times I ever heard the two being mentioned side by side, other than on my transcript, came from an unlikely place: Spider-Man. When the pandemic hit, I started rewatching Spider-Man, the animated series from the 1990s. Mary Jane Watson said, "You know, physics is a lot like theater. I get it now. It's all about trying to make sense out of life." Since then, when I began this project, I also discovered the book Quantum Theater by Paul Johnson, which also takes an interdisciplinary approach to theater and physics, and a lot of the book uses quantum mechanics to provide a new perspective and working framework for theatrical performance. Theater actually originated from the same practices and conventions as marriages and graduation ceremonies. These aspects are so important and ingrained in our modern society. And physics isn't just about weird math or talking about small particles that you've never even heard of. It's also in the natural world that you live in and in the technology that you use every day. I hope you enjoy some animations and graphics that look like they were probably done using the 1990s version of PowerPoint. You'll maybe guess neither of my degrees were in graphic design. And of course, I can't fit everything into a singular video, but nevertheless, I hope you enjoy this presentation, learn something new, and maybe you can learn a new perspective on theater and physics. So, why is theater so important? We ask ourselves this because it's often called into question how exactly are the arts, or specifically theater, relevant or significant to everyday life. While it's actually quite common for the arts to be considered afterthoughts or not as important, or even just productive careers, there's actively art all around us. Whether you like movies or TV shows or creative writing or just even music, this is all art that is openly available to you. So part of answering the question of why theater or even just storytelling is significant or important, we actually have to look back at its origins, how it began. Storytelling is universal, both in time and in space across the world. Throughout the history of the Homo sapien, storytelling has occurred across the globe. From since we were cavemen sitting around a fire, to ancient religious dances, to sacred carvings and art, we had been telling stories. Before we had such advanced technology and transportation to go and meet and talk in person with someone across the world, or communications like phones and the internet, people were not able to share or imitate or copy ideas as much from someone who is halfway around the world. However, all these isolated groups together at the same time were doing the same things. Many theatrics have been said to have originated from religious rituals or societal ceremonies. They all have a certain setup that they have to follow, certain clothing that's supposed to be worn, and a certain setup and certain words that are supposed to be said. Sometimes there are dances, processions, or even acting out past occurrences.
Well, one of the most important things about all of the fine and performing arts is that we are kind of written into the DNA of humans and humanity. Going all the way back to the very earliest stages of human development, you see humans wanting to imitate, role play, and storytell. And so how they choose to do that and in which format is how we developed dance, theater, visual art, and music. The fact that from the very beginning those forms of expression are the primary and the first ways in which humans try to communicate and try to develop their relationships and storytelling and find meaning and their place in the universe is a pretty substantial thing. You know, and looking at every major time period in human history, both in kind of the Western world and in the Eastern world, we see that theater has always played a significant part in the cultural development, the sociological development of a culture or of a society. We see that it is influenced by religious practices. We see that it has been influenced by politics, and vice versa, that theater and dance can influence the culture, the society, and the politics of the day. So we have a lot of different productions of plays, musicals, dance pieces, operas that have been significantly impactful into the way in which people look at an issue, a political issue, a sociological issue. They have also been impactful in the way in which we look at technology and the way in which we look at inclusionary practices. So you're thinking about equity and thinking about diversity and using art as a way to bring up conversations and discussions that need to happen in order for society to improve and to get better.
We also see theatrical roots in popular entertainment in history. Whether it was juggling or skits or singing or dancing, we see elements of theater in all of these. Some of these have been around for thousands of years. We see all of this form theater as we know it today. We also see this repetition of other things that have happened within human nature. Even as a child, we have the need to imitate. We imitate those we see. It's how we learn, grow, and develop as children and all the way into adulthood. It can still be necessary to imitate, even in new situations as an adult. Learning and seeing what others do can be an important part of being human. My arguments would be most, if not all, of fiction can fall into three of these important purposes: education, escaping, and entertainment. Entertainment, pretty straightforward. We find joy in simple interest in a show or story. But what about education? And I'm not just referring to math or science, but we'll be getting to that. I'm talking about something deeper and thought-provoking: philosophy, life lessons. And specifically with storytelling and theater, I want to reiterate the point of the types of lessons that we learn from them.
You know, there are so many examples of plays that dealt with some kind of a sociological issue. If we go back all the way to the golden age of Greece or Rome, I think we will find a lot of examples of plays that did that. You know, whether it be everything from Oedipus Rex, which was a very didactic play in terms of helping ancient Greeks understand the role and power of the gods versus the power of man, this struggle between humanism and religious belief. But we also see plays like, for example, you know, coming out of the Roman golden age of theater, which helped to promote the philosophies of Stoicism, right? So in a play called Thyestes, where we see again the value of Stoic behavior. So that's a huge component too. But I think another play that had a long-standing kind of political implication, of which there are so many, is Greek comedies written by Aristophanes. Specifically looks at a unique political problem that was affecting Greece at the time, and that is warfare, to go back to warfare. And the women of this town, it's a comedy, but the women of this town and the neighboring villages and towns that are also embroiled in this warfare, they get tired of being at war and having their husbands be at war and their husbands dying for causes that they felt were pretty ridiculous, or having their sons going off to war and dying for what they felt were pretty ridiculous reasons. And so they banded together as women and went on a sex strike. And so they said, okay, we're not going to have relationships with our husbands until this war is over. And it's a comedic approach to trying to get people to think about why they are at war in the first place. But it also plays into the idea of, you know, trying to draw focus using comedy to really get the audience to think about, okay, why is it that we choose to go to war so easily? And what are the fact that a war could be stopped simply because the wives go on a sex strike, how ridiculous, but how ridiculous is it that they had to go to that length to get people to stop, to come together, and to have a conversation about peace and the way to move forward?
First, I will start off specifically with philosophy and ethics, and how storytelling is so vital to it. Philosophy and life lessons are crucial for existing as well as living in a society. How we treat people, how we learn how to act, how we can be educated on topics we're ignorant of, all of this is important. Philosophy and ethics help us decide what should we do for our family, what is love, what is important in a job, what actions are morally wrong, what is worth fighting for, etc. It helps us navigate our actions in the world we live in, which is a very significant aspect of the human experience. Storytelling plays an important role in this. People like to be shown, not told. Whether a child or a grown adult set in their ways and beliefs, sometimes just being instructed explicitly is not going to get the job done. Sometimes for a child, watching a TV show they enjoy that teaches manners and good behavior is actually what teaches them what is good to do. Sometimes adults need to face a situation, not in a careless, secondhand way, but firsthand. They need to hear stories from someone they know and trust, or come from a source that they are invested in to realize things. People need to sometimes think they come to conclusions on their own, or they simply just need to learn something at their own pace. The book, The Moral of the Story, an anthology of ethics through literature, is a great starting basis for this point and type of information, showing that storytelling and writing can be more than just pieces of art, but also life lessons and important cultural comments for its audience and readers. It has also explained how this can have a crucial role in education, ethics, and how we live our lives as human beings and how we live in our societies.
The moral of the story says in its prologue, long before the rise of systematic philosophical thought, however, people have been making up stories in order to convey what they think how we ought to live. Inevitably, in telling stories and in writing novels, plays, short stories, and poems, the authors and narrators raise moral questions and suggest possible ways of answering them. Thus, ethics comes squarely within the field of literature as well as within the field of philosophy.
You can also tell the significance of this style of storytelling in human history. Plato's Ring story, the tales of the rabbit and the hare, Aesop's fables, parables and religious texts, and allegories, and even metaphorical stories.
The moral of the story goes on to say, a good philosopher states positions clearly, and readers know what they are being asked to accept and why. The use of fictional examples is often part of this process. Plato used a story about a ring that made the wearer invisible in order to raise the question whether we only do what is right because we are fearful of being punished if we do not. The book goes on to add, and I really enjoy this, nevertheless, for philosophers, the example is merely a tool, like a piece of equipment for a scientist.
So, the importance of physics. The everyday person may think, how does this apply to me? Why do I care about atoms or math or these weird concepts of physics on Earth, nuclear science or lasers or hadron colliders, whatever that is? Then like medical stuff, or common inventions created by physicists. Now, the vast field of physics, one of the only sciences that ranges from the smallest subatomic particles on Earth to the vastest stars light years away. So, this can sometimes make it difficult to understand why exactly is this an important field to the everyday person. So, to explain some of the significance of physics in your everyday life, I'm going to take you through natural occurrences in nature that happen around you every day, and then to man-made instruments that are involved in a modern person's everyday life. This will mostly be talking about physics concepts themselves, and then how they are relevant, or talking about important, dangerous, and or common occurrences and the important physics behind them. Also, there are so many examples and explanations for so many physics-related phenomenon in the everyday world, so this is quite abbreviated.
Okay. So why physics is important in everyday life? So I always consider physics is a queen of sciences. Why? All right. You start walking. You don't understand, I can walk properly, but try to walk on an ice skating rink. Can you walk properly? No, you fall down. Why? That is explained by physics. And you all know we can walk on the ground because of friction, but when you go to ice skating rink, it is less friction. All right, let's take one more example. You drive the car, suddenly somebody crossing the road, you slam the brake, and you start seeing smoke coming out from the tire. Why? Nobody lit your car on fire, but still you see the smoke. What's the reason? Physics explains. The car is moving with some energy, kinetic energy. That's a technical jargon we use, but what is kinetic energy? The car has some energy because it is moving. Now, once you slam the brake, where does that energy go? That is transformed into heat, and that's what you are seeing it coming from the tire. So that is what I always say, the universe came into existence with some energy and some mass, and if energy is transformed into mass, energy would decrease, mass would increase, or vice versa. I always tell my students, universe doesn't have a credit card. It has to live within the mean. So that's why physics teaches not only basic aspect of how things happen in the universe, around your house, around your life, but also it teaches how to manage your finance. So physics can also explain finance.
Everyone knows a little bit about physics in a sense. Throwing a ball in the path that it takes, or realizing that a semi is more dangerous than a car traveling at the same speed because of its weight, and from that, its momentum. What people don't really understand is the technical aspect of it. That momentum is mass times velocity. That why the semi has a higher momentum and is more dangerous. So, there's the physics of heat, a natural phenomenon. A basic use of physics is using heat or fire to heat up the food you eat. Fire basically is heat, that is energy that can transfer from a warmer substance to a colder one. When you use a stove, the coil, flame, or cooktop transfers heat to the pot or pan that is set on top of it. Then, the heat from the pot or pan is transferred to the food inside. However, common science knowledge or the physics of oil and water can be a lifesaver. Grease fires. Do not use water on a grease fire. It will only cause the fire to get bigger. With a grease fire, if you're able to, cover and smother it. This removes oxygen, which is what a fire needs to burn. Do not ever pick it up because since oil is a liquid, it can still easily splash on you or the floor, injuring you and or spread the fire. But why? Oil is lighter than water. We're used to the demonstration of if you pour oil into a cup of water, it will simply stay on top. They don't mix together. Because of this, the water won't interact with the oil enough to be able to put it out. What actually happens is that the oil burns at much higher temperature than water boils. So, when you throw water onto a grease fire, the water sinks below the oil and is flash boiled to steam by the intense heat, which blows the oil out like a small explosion. This causes the oil to break into tiny droplets, which can be expelled in every direction. Since oil is lighter, the water also being a liquid would make the fire able to move around just as easily as a liquid. So it's extremely dangerous and can be difficult to control if it gets out of hand or is moved in an uncontrolled way, since it can easily splash. Another important part of physics relating to fires is smoke inhalation. Smoke inhalation is the most common cause of death in house fires. So, on to the simple fact. Hot air rises. When heat is supplied to air, the gas molecules gain kinetic energy and bump into each other more often, and with greater force. Basically, they get more energy, they're moving around faster, so there's more space between them. So, they're not as dense. This makes the cooler air, or air that's relatively cooler, fall beneath it, replacing it. As that cool air heats up, it too will rise, and as the original hot air cools, it will fall again. This is called a convection current. Most deaths from indoor fires are not from being burnt by bare flames, but from smoke inhalation and carbon monoxide poisoning. When various household items are burning, incomplete combustion takes place. Complete combustion of hydrocarbons, molecules made out of carbon and hydrogen only, produces carbon dioxide and water, while incomplete combustion of hydrocarbons produces a combination of carbon dioxide, carbon monoxide, carbon, and water. In the event of a fire, the intense heat generated by the flames will cause the surrounding air to expand and rise like we discussed. A large percentage of the surrounding air will be smoke and other harmful gases produced by incomplete combustion. Therefore, to avoid such gases and to buy yourself more time, all you have to do is get down on all fours as low as possible to the ground. That position will allow you to inhale as little of the smoke as possible, since most of it would have risen to the ceiling. Lightning is also a very important phenomenon to be careful of. Lightning kills more than hurricanes and tornadoes every year in the United States.
Electricity, the lightning. Now we know it is because the electric charges discharge between clouds. But 2000 years ago, did we know that? No. But did we have lightning? Yes. But people did not know. The nature always gives us a clue to understand what is going on. But the only thing is now we are at a point using our physics knowledge to understand. So I would always say physics explains everything, but not completely everything. But physics is trying to make us understand what is happening in the nature.
Some inventions that we currently have today have been so important and have been widely used in everyday life. Even complicated sounding physics such as the quantum theory of solids has led to semiconductors and computer chips. And nuclear magnetic resonance has led to MRI imaging, and particle accelerators have led to beams for cancer treatments. All of these things are very important inventions. Now, onto something that you've probably heard a lot about, but seems so advanced or mysterious that you may not know you use this physics every day. Relativity. Sounds like some scholarly physics concept that has no application to everyday life, right? Wrong. Relativity plays a key role in a multi-billion-dollar growth industry centered around the Global Positioning System, the GPS. The satellites surrounding the Earth experience gravity that is 4 times weaker than that on the ground. Einstein's general relativity theory basically says that gravity curves space and time. The net result in that time on a GPS satellite clock advances faster than a clock on the ground by about 38 microseconds per day. GPS accounts for relativity by electronically adjusting the rates of the satellite clocks, by building mathematical corrections into the computer chips, which solves for the user's location. Without the proper application of relativity, GPS would fail in its navigational functions within about 2 minutes. So, quantum mechanics comes along. One of the main things to come out of quantum mechanics is uncertainty, and that electrons are promoted up in an energy from a photon, or light, or electrons. So, studying a specific type of material and determining the energy required to get an electron to be promoted to a sufficient energy level, you can get a certain frequency. A good example of an invention based off of this new knowledge is LED light bulbs, which are also quite efficient, lighting up roads and highways, improving safety every day. Speaking of roads, let's also talk about F equals ma, and how important that can be for driving safety. Now, also with cars, specifically seat belts. Again, we've heard F equals ma. When a car is going fast and say, hit something, like a wall or a telephone pole, the car goes from being in motion to zero very, very quickly. Newton's second law of motion helps us describe why a seatbelt is so important in surviving a crash. If you view acceleration as negative or decelerating, F equals ma also tells us it takes a high force to decelerate, or slow down an object with higher mass. Also, the slower you're going, the less amount of force will be present. A seatbelt slows down your body's motion just a bit more gradually. There is less force being enacted on your body, and also the seatbelt fights against the force pushing you forward. Your body is also moving with the car. That means if your car is going 50, 60, 70, or 80 miles per hour, so is your body. Without a seatbelt, if your car wrecks, your body will still continue to travel that quickly. Up into the mid to late 1800s, everything was about dynamics and statics. Moving objects and stationary objects, and also energy. Then thermodynamics comes around and says that mechanical work can be energy, the foundation of the internal combustion engine.
We are not doing something new. We are trying to understand what is happening in the nature, and that is what physics that explains everything that you do in your life. How does your body move? All these mechanical part governed by Newton's laws. How do you walk? Newton's laws. When the car is stopped, heat is produced. How do you explain that? Energy conservation and so forth. So these are the simple examples that we always encounter in our life. So that is what I chose, those examples to explain why physics is important in everyday life.
Also, air conditioning, refrigeration, heating, and power plants. So whether it's the AC or the fridge, the temperature of your house or the temperature of your food, that's physics at work in the inventions you use every day. Without this knowledge, we wouldn't be able to stay warm in the winter and cool in the summer, or be able to fly or drive. But the main thing to remember is that a lot of this wasn't a leap ahead. It was merely a consequence of understanding dynamics and statics and applying it to different scenarios and understanding energy. As a homeowner or a car owner, you don't have to know how that object works, but it helps tremendously if you do. If you have water in your basement and you think, oh, a pipe is busted, you know the pipe is busted, and therefore you know something about plumbing and owning a house. You may not know how to fix the pipe, but you know what the problem is. Physics is similar to this. The math is essentially knowing how to fix the busted pipe. Knowing the pipe is ruptured is knowing concepts of physics. Also, existing in the earth for as many years as you have shows that you know a little bit about physics as well. You know that power shocks you and that it could potentially kill you. You know physics, you know the operating principles of it. Knowing more will help you in the long run. Now, onto the combination, the interdisciplinary possibilities of both theater and physics. Of course, a way of going about this is to just talk about theater shows, plays or musicals that have physics topics, or educational shows that are fun, but still teach or mention or even at least use science. It should also be noted that some of this will also just be art in general, not specifically theater, and some will be about science in general, not just specifically physics. But it can go even further. How about offstage, or outside of a live performance? How can physics affect theater? Or, better yet, how can the two go hand in hand as equals? Of course, there's the literal physics behind theater. There's the use of counterweight systems, electricity, use of color and pulleys, and maybe even pyrotechnics. Companies such as Cirque du Soleil need engineers to build stages that are visually captivating, daring, but still ultimately safe. One way we see the combination of arts and science is in people that are involved in both of the fields. We've all heard of Leonardo da Vinci. We all know his iconic artistic works of the Mona Lisa, the Last Supper, and the Vitruvian Man. But while being incredibly successful in this field, to the point that we are still talking about this man 500, 600 years later, he was also an intelligent scientist, inventor, and engineer. He designed one of the first things known as a diving suit. He had designs for a water wheel and the first life preservers. He was also a pioneer of anatomy and dissected over 30 human corpses. Da Vinci being the one to illustrate the diagrams was certainly a way to combine the arts and sciences. Through this, he even specifically believed that arteries can clog over time, something that no one else had investigated at this point. Since his findings were published, it took till the 20th century to realize his beliefs about the heart valves and functions were actually correct. He was an amazing artist and still gave incredible and insightful discoveries to the scientific community. We also can mention a couple musicians, my favorites, rock musicians. Dexter Holland of the American rock band The Offspring has his PhD in molecular biology from the University of Southern California, which he received in 2017. His thesis was entitled Discovery of Mature Micro-RNA Sequences Within the Protein Coding Regions of Global HIV-1 Genomes, Predictions of Novel Mechanisms for Viral Infection and Pathogenicity. From the classic rock band Queen, Brian May, their guitarist, received his PhD in astrophysics from Imperial College in May 2007. His PhD thesis was a survey of radial velocities in the zodiacal dust cloud.
So, how can you apply physics to art? I would say music is part of the art. So whether it is a symphony orchestra or NKU's Philharmonic Orchestra, they all try to tune their instruments before they start playing wonderful music. How do they tune? Probably concert master or the oboe player who starts playing a note, and everybody else is trying to adjust their string instrument and every other instrument to make sure that the note produced by all the instruments are in sync with the note produced by the oboe. How does it happen? It is what we call in physics resonance. That means when all the frequency matches, you hear the harmonious note or loud note, instead of if all those different instruments are at a different note, that would produce totally what you call cacophony. So yes, the resonance, the concept of frequency matching among all the different instruments is what we call resonance. That could be easily applied to music, and that is what I think the application of physics into arts, especially into music. And that's why we have a movie called Sound of Music. Thank you.
Now, in the theatrical environment, there are things we can learn through physics. There's an article entitled Acting Concepts Through the Lens of Physics. The author says he started as a research scientist in the physics department of Boston University and then moved to New York City to pursue acting. In physics, we often look at a chosen system and learn how it's influenced by an outside force. Newton's first law of motion is that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an outside force. It's also called the principle of inertia, a body's aversion to change without an outside force. Physics looks at how things change over time. The author particularly cites this graph as an example. The concept of trajectory and change. Trajectory here is how systems or an object's position changes with time. In terms of physics, he says, the system can be as simple as a ball, and the force can be imparted by a baseball bat. It could also be more complex as the interaction of light with a solid. When an actor presents a monologue, the text he presents is the external force or influence, and the system is the actor itself. It's interesting to see how actions in a play affect and change a character, and how words and choices in a monologue can affect and change an actor. We can find interest in how a character evolves, but also in how the actor themselves can, in just delivering a moving piece. How the actor evolves with time under the influence of the text. In physics, we also talk about initial conditions and what state a system or object is in at a certain point in its change. Depending on the initial state and the initial conditions, this can change the evolution of a system. In this graph, we see that an object starting at a different position changes the way it travels and how the graph of its position can change. Just how velocity and position can change at different rates throughout a change of a system, an actor can undergo crests and troughs of emotions. An actor can also go through different levels of intensity. Sometimes things are fixed and stay the same, thus making it dramatic. And, like a chaotic system, something that we can't always predict how it will behave, is like an audience, or even an actor themselves, being open to the ending state, the ending possibilities, and the journey they can go on throughout a performance. An audience doesn't know exactly how a play will go. An actor never gives the same performance, so even they can be unsure of the specific ways their emotions will occur and to what intensity. Art can be like an outside force for someone. What happens to a human being or a character in a play, they change because of what happens around them. This is also dynamics in physics. Possibly in a more metaphorical or mental sense, but the writer says it compares instead of standing in my way. Physics gives me an added layer of imagination to understand acting concepts and how to apply them in my work.
So there are two plays that I think of when I'm looking at kind of the confluence of science and art. One of them is a play called The Curious Incident of the Dog in the Nighttime. This particular play was an adaptation of a novel of the same name, and it was originally produced by the National Theatre in London. What's cool about this play is that it is an exploration of how one individual, a boy by the name of Christopher, experiences the world around him. He is a neurodiverse individual, and so the design team that were specifically looking at how to approach reflecting Christopher's world used so many different forms of science and technology to recreate that world for us as an audience, to get a glimpse into how he might experience the world around him. And so what I love about that particular design and production is that they used projection mapping technology, new kinds of lighting equipment that had not been used before or hadn't been used in a specific way for this production. And then they also, of course, used the science, medical science, specifically looking at what neurodiversity is, and how can we share that with our audiences to enlighten them and to give them an opportunity to see the universality of human experiences, and to share humanity, and to realize that the differences that we might perceive of being between people are actually so minuscule once we open up our minds and our hearts to that. And so that particular production is a great example of how technology can be used to further a story or storytelling.
The American Physical Society, APS, wrote an article about how the physical sciences are the subject of many thriving plays and how science is being used in artistic forms like dances and operas. The playwright Lauren Gunderson said, "The thing for me that has always and continues to be the reason I write about science is because it's inherently dramatic. There is abundant character and inherent plot. I think on a more existential level, science lets us talk about the biggest ideas, and I think that keeps theater relevant and philosophical, in a way I think people crave when they go to the theater." Gunderson is just one example of a playwright with a science-influenced or themed play. She actually has multiple, particularly about physics. Background is about the life of the physicist Ralph Alpher. The Amazing Adventures of Dr. Wonderful and Her Dog tells the story of a 5th grade girl who uses science to solve mysteries. Gunderson was also instrumental in setting up the Playwright in Residence program at the Kavli Institute of Theoretical Physics in Santa Barbara. There's also the play The Effects of Gamma Rays on Man in the Moon Marigolds, written by Paul Zendel, a playwright and a science teacher, which was made into a film in 1972. The famous 2005 opera Dr. Atomic, written by John Adams and Peter Sellers, highlighted the ethical conundrum felt by Robert Oppenheimer and other members of the Manhattan Project as they labored to produce the atomic bomb. Similarly, there was an earlier work dealing with the morality of physics and physicists in Michael Frayn's 1998 play, Copenhagen, about Niels Bohr and Werner Heisenberg's mysterious meeting in Denmark in the early days of World War II. The performance is an examination of what exactly transpired between the two physicists and launches into a philosophical discussion over the morality of scientists and the atomic bomb. Frayne had an interesting quote about his play. "The intention was not to write a play about science or a moral tract or even a moral or ethical examination. It was to write a story about why humans do what they do. If you are to make any moral judgments on anyone, you have to understand their actions." Lisa Perry, a playwright based in Cardiff, Wales, has a belief that she has spoken about many times. It's that theater needs to engage with science and ethics in order to remain relevant. In a talk, she once said, "Algebra and poetry may have the same pure heart, but one's written in words and one in numbers. We speak different languages. Education tells artists that science is hard, but as communities, we rarely talk to each other. And it's exciting to have these conversations. An artist may think, how can math be beautiful? But it describes everything around us. Mathematics can really be called the language of nature, or the language of the entire universe. Everything on this planet, living and dead. It describes everything. Physics is just applied mathematics. Math and physics describe what's going on, and art is how we experience it and how we feel it." Also, just from even a personal experience, the feeling of just learning and being more aware of our world, as Helen Sirski said, just not feeling as lost. Being able to see connections in everything around you. In my honors studies during my time in undergraduate school, a big focus, particularly in our introductory classes, was focusing on interdisciplinary relationships of different academic fields. Not just that they can all be interesting separately, but can also be fulfilling and enlightening together. There's a certain type of fun or laugh you have to have when you walk into your Calculus 2 class with still the remnants from your stage makeup class still on your face. It's cool being able to see the science side of things that you're interested in being played on stage. The book Quantum Theater says both theater and physics attempt, albeit in radically different ways, to understand the world and our place in it. Our scientific views on reality can profoundly alter our artistic sensibilities in these interactions and should be traced. Saying later, while their methods differ radically, artists and physicists share the desire to investigate the ways the interlocking pieces of reality fit together. This is the common ground upon which they meet.